Unit 4A, calculating measures of variability, standard deviation, variance, and range from a sample distribution of individual scores. The ages of a sample of 5 seals at the zoo are 3, 21, 3, 9, and 4 years. Calculate 3 measures of variability for these sample scores. The first measure of variability is called the range. The range is the highest score minus the lowest score. The highest score in this distribution, notice the distribution has been sorted, is 21, and the lowest is 3. 21 minus 3 is 18. So the range of this distribution is 18. To see visually what this means, here's a dot diagram for the distribution. Here is the lowest score. There is the highest score. This distance between the lowest score and the highest score is the range. Now, if you wanted to, you could put in all these ticks and then count how many boxes between the highest score and the lowest score. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 boxes between the lowest score and the highest score. By the formula, we just take 21 and subtract the lowest, the max minus the min, and you get 18. So the range of this distribution is 18. A population variance, sigma squared, is given by the formula sigma squared. The variance of a population is equal to the sum of the squared deviations divided by n. It's you can think of it as the mean of the squared deviations. For a sample, it's similar, but the formula is s squared, sample standard deviation, equals the sum of the squared deviations, but in this case, you divide by n minus 1, the sample size minus 1, which is also called degrees of freedom. Let's see how this works. For our scores, the first step would be to find the mean. So in that case, we would add the x's together, get sigma x, and that would be 40, divided by 1, 2, 3, 4, 5 scores. So that would be 8. Now we calculate the deviations. Deviation is score minus mean, or in this case, score minus 8. So we subtract 8 from each of the scores. 3 minus 8. That's negative 5. 3 minus 8 again, negative 5. 4 minus 8, negative 4. 9 minus 8, positive 1. And 21 minus 8, positive 13. Now, when thinking about variance, we might want to get the average deviation from the mean and consider that to be the variance. However, the problem with that is the sum of the deviations is always 0. If you add the positives, positive 14. If you add the negative deviations, you get negative 14. They are opposites, and you get 0. So to get the average deviation would not be helpful because the average deviation is 0. But we are interested in the spread of the scores. How far away are they from the mean? Well, the way to take care of that, one way anyway, is to square the deviations and get rid of all those negative signs. So when we square the deviations, negative 5 squared, 25, negative 5 squared, 25, negative 4 squared, 16, 1 squared is 1, and 13 squared is 169. Well, here's the chart we had on the previous slide. To get the sample variance, we get the sum of the squared deviations divided by degrees of freedom. The sum of the squared deviations would be 236. That's the sum of the squared deviation column, 236, over n minus 1. N is the sample size, 1, 2, 3, 4, 5. 5 minus 1. So that would be 236 divided by 4. And that comes out to be 59. So the variance would be 59. For a population, the standard deviation, sigma, is the sum of the squared deviations over the population size, or the square root of sigma squared. That's the variance. Similarly, for a sample S, the standard deviation is the square root of the sum of the squared deviations divided by degrees of freedom, or that's the square root of the sample variance. So to get S, we need to take the square root of S squared, which we saw was 59. So that would give us approximately 7.7. In summary, we had the range was 18. The variance for this sample was 59, and the standard deviation is approximately 7.7. Now there is a rule of thumb that approximately works, and it says the standard deviation, which in this case 7.7, should be approximately a quarter of the range, which was 18. Well, it's only a rule of thumb, which means it doesn't come out exactly all the time. A quarter of 18 is 4.5. So they're not too close in this case, but normally they come out, that comes out to be a reasonable check. You can find S on the TI-84 in a similar manner to the way you found means. Clear the machine, enter the scores into L1, press stat, calculate one variable statistics. Your list would be L1. There is no frequency column, so leave that blank. And navigate down to calculate, press enter, and you'll see SX, which is the TI version of S. So S is about 7.7. Same thing we had by hand. If the outlier 200 is added to the previous sample, how will the measures of variability be affected? We're going to add 200 to the distribution. Now the range would be the highest score, which is now 200, minus the lowest. 200 minus 3, or 197. I'm going to have to get the mean in order to calculate the other two measures of variability. So the mean would be the sum of the scores, which would be 240, divided by the 1, 2, 3, 4, 5, 6 scores. We have the sample size is 6, and that gives us a mean of 40. Now to get the standard deviation and the variance, we would have to take score minus the mean, which is 40, so x minus 40. So 3 minus 40, negative 37. 3 minus 40 again, negative 37. 4 minus 40, negative 36. 9 minus 40, negative 31. 21 minus 40, negative 19. 200 minus 40, 160. Then all these scores, all these deviations have to be squared, getting these numbers, sum them up, and we have the sum of the squared deviations. So to get the sample standard deviation, it's the sum of these squared deviations divided by degrees of freedom. We have 1, 2, 3, 4, 5, 6 scores. So degrees of freedom is 1 less than that, or 5. That goes down here. If we divide these two numbers, we get 6191, and take the square root, we get 78.68, etc. That would be our sample standard deviation. To get the variance, we square the sample standard deviation, and we get 6191, and notice that's the same number that was in the radicand before. Comparing our original distribution with the outlier, notice that the range was 18 originally, and now it goes with the outlier out here. The range goes all the way out to here, to 197. It was about 10 times as large, the range. The standard deviation was 7.7. It increased to 79, again about 10 times as large. The variance went to from 59 to 6,191. That was about 100 times larger. So all of these measures of variation are going to be seriously affected by the outlier. That's the end of Unit 4A. See Unit 4B for measures of variability from frequency distributions.